So we stopped here before the midterm exam at understanding the concept and modeling of linear programming. I have revised this file on Blackboard because we don't have time now, so we have to we'll see as much as possible we can cover, because even one problem is enough to understand how to formulate the model and solve it. So we'll just stop at maximization, okay? We'll not go to the minimization. So this was the file. It was uploaded earlier, but I have changed it. Now you will have just till here, okay? So we'll just cover this much. And today, we'll learn how to solve this, how to find the values of x1 and x2 by graphical method, okay? So that's our agenda for today, and with this we will complete linear programming. And in fact, we have covered a large part of the syllabus. Almost all the topics have been covered here and there, but I still want to continue in the next week, if possible. If there is a possibility of class, then next Sunday, or otherwise, we can take a special lecture on any day before or after Sunday, so that we just have a review class for I can cover a summary of the various topics, 2 or 3 topics that are left, like queuing or waiting line or decision analysis, if it is possible. But if it's generally not okay, means it's not allowed to take the classes any further, then we'll just stop at here, okay? So let's see how it happens in this week. What is okay, there are some students who are not able to log in. I don't know what is the problem. Today morning when I opened the Blackboard, there was some problem in the Collaborate. They have perhaps, so ask them to just log out or try to log in again. Yeah, so let's start. Okay, so just for a revision, I hope the screen is clear on your side and you can hear me properly also. Okay, so we formulated this problem in the last class, that we had this problem. There was a company that wanted to produce 2 products, and there is different profit per unit from both of them. And the question to be solved is how many of each of the products will need to be produced to maximize the profit. That was the main question. So we had discussed the formulation of the problem right till this part. We came here and we finally formulated the problem, taking all the constraints. And the final model is that we have to maximize the objective function. The formula of the objective function is plus 40x1 plus 50x2. 40 and 50 are the parameter. These are the profit per unit. So when we multiply it by the number of bowls and mugs, we get the total profit. Okay, so let's start from this part. So in the file lecture number 10 of solution, you will see that there are just slides because there is an attachment. There is another file which is LPP maximization. So we'll just go through this file first. Okay, we'll see this part of the chapter in the book. Okay, and then I'll show you how to solve. So we have already formulated the problem. We learned how to solve the problem. Now, look at here. This is the graphical solution of linear programming models. So you have to read from here. Everything is clear, very well explained in the book. So if you read it, you will be able to follow properly. Okay, so in this problem, the method that we are going to use is the graphical solution method. Okay, so I'll add a blank slide here, and then we'll solve. Okay. All right. So now please pay attention carefully. Okay, because we are going to now solve. Now, in the first of all, the method that we are using is called graphical solution method. Graphical method to solve graphical method. Okay, and there are other methods also, like there is a method called simplex to solve linear programming problems, and obviously there is computerized method, computer solutions, where you have to enter the parameters and use the method, and it will give you the output. But we want to find the value using the graphical method. So in the graphical method, what we do, as the name suggests very clearly, we have to do something with the graph. Okay, we have to do with the graph. And what is the role of the graph in this? The role of the graph is because why this method is better, because it will also help us see a linear relationship, because we know that linear programming always includes linear relationship between the variables in the objective and the constraints. Okay, so the first task in solving through graphical method, so we'll try to memorize the steps. Okay, what are the main steps? Because management science or operations research is mainly about the algorithm, the steps, what comes first, then second. So the first step, are you all with me? You all can hear me? Let me just check how many students are there right now. Although I am recording, but it's always good to join live. Let me just check how many students are there now. There are just 17. Oh, many are missing today. So let me just check again. You all can hear me, and the screen is clear on your side. You can see the screen. Okay, thank you. So let's start. Okay, so now let's look at the first step, step number 1. Okay, and please keep noting down in your notebook. Okay, so you don't forget it. The first step in graphical method is that first of all, in finding the solution, we have to work with the constraints first. We have to work with the constraints. These are the two constraints in the model. So what we have to do, the first step in the method is to plot these constraint equations, plot these constraint equations on graph, right? So this is our step number 1. Now we have two equations, so we'll get two lines. Okay, we have to do it 2 times separately. So this is our equation number 1, and this is our equation number 2. So the first step. So what we do, let's write down the equations. Here, let's write down here. There is this empty space. 1x1 plus, and now you can please help me by writing on the group so that I don't have to switch again and again. 1x plus plus 2x2 is equal to 40. 2x2 is equal to 40. Here, there is an assumption, but it's a logical assumption that we are going to consume all 40. It is not less than, because in the equation, we write that it is less than or equal to, but we are assuming something. You understand? Assume. We are just assuming that the company is going to use the full 40 hours of labor and 120 pounds of clay. So if you assume that all full are used, then there is no need to put this less than, but rather just equal to sign. So this is our first equation. Number 2 equation is 4x1. Let's write it down here. 4x1 plus 3x2 is equal to 120. There are a few steps to follow before we plot it on the graph. Remember it. So the first step in solving linear programming through graphical method is to plot the constraints on the graph, not the objective function. Okay, we have to plot the constraints of the graph, right? So let's take number 1. Number 1. Before we understand how to do this, let's look at the graph first. What is required to make a graph? So this is the graph. This is the x-axis, and here we have 2 variables. One is x1 and the other is x2. Okay, the one is x1 and the other is x2, x and y. So what do we need to plot? We need the values of x1 and x2. Where are we going to get these values of x1 and x2? It's not given because both are in letters, in variables. So how to do that? Here, that's the step. Listen carefully. Here the rule is, first assume, before we solve, we have to assume any one variable as 0 first. We'll assume that, assume x2 equals 0. It's an assumption, but it's a rule. You have to follow that. We assume that x2 is 0. So what happens? Can we solve now? Tell me. What will be the value? And please write on the group, okay? WhatsApp group, not on Blackboard, because I cannot check. So what will be the value if I say x2 is 0? Then what happens? 1x1 plus 2 into 0 is equal to 40. Okay, so what happens? 1x1 plus 0 is equal to 40. So x1 is equal to 40. So we got one value. Okay, we got one value, and that value is 40. So let's say we use this as 20 as it is done in the book. We'll use the same calibration so that you don't make a mistake. keep it here. Now we'll use the same. Yeah, 10, 20. Oh, it's a interval of 10 each. So we'll use the same. We'll not change it. Okay. So we'll use the same 10, 10. But you have to do it on the graph paper, not on plain paper. So when you what happened? When you use the graph paper, it will be giving you. You don't have to make these calibrations yourself. It will be done. So this is 10, then 20, 30, 40. Okay, so and so on. 50. We can extend it 60, 70. And so here x2. And there is a rule also to follow to decide how much should be the. So what we do, we normally take the minimum and the maximum value, and then we give the value. So here, first of all, we got the first value, that is x1 as 40. So x1 is here. Okay, this point. Now we have to find the value of x2. Now tell me, any guess? What should we do? In the first step, we assumed x2 as 0. Okay. In the second step, in order to find x2, we will assume x1 as 0. Okay. So we assume x1 as 0. So if we assume x1 as 0, this becomes 0 plus 2x2 is equal to 40. So tell me, how much will be the value of x2? x2 will be, x2 is equal to 40 divided by 2. So the value will be 20. So we got two values. We got the value of 20 also. And then let's solve the problem here as well. You do it yourself. Okay. Follow the same steps. And now tell me what will be the value of x1 and x2 for equation number 2. This is equation number 2. This is equation number 1. Equation number 1 means constant number 1 and constant number 2. So let me know. Try to solve it yourself. Just do the same process as we did, and we'll have 4 values, x1, 2, and x2. So take your time and just solve yourself. 4x1 plus 3x2 is equal to 120. So find the values of x1 and x2 for constant number 2. Let's see who can answer first. It's very easy. Just follow the same step and tell me what are the values. X1 is 120. Really? Abrar says x1 is 120. x1 is equal to 120. The first answer is from Abrar. Okay. What about others? Any other answer is there? What about x2? This is the most important step in the graphical solution, because if you are able to find the values of x1 and x2 for both the constants properly, then rest of the solution is easy, because then we have to just do some simple multiplications and addition. Are you trying to solve? Let me see what is the value you are getting for x1 and x2 for equation number 2. You know what you have to do? You have to first assume x1 as 0, and then you have to assume x2 as 0. and then you will get both the values. So try to do it yourself. Do it first. Okay, very good. So we got another answer from Razan. So it's different from Abrar. What is the answer Razan has given? Razan says x1 is 30. Razan. And x2 is 40. This is also Razan. And we have got another answer from Tala. Tala says x2 is 40. She agrees with Razan. Okay, so let's solve it and see. It's easy. So what we do, we first say x1 is 0 plus 3x2 is equal to 120. So x2 is equal to, this became 0, okay? So 3x2 is equal to 120. So 120 divided by 3 is 40. All right. Then what we do, we repeat the same by taking this as 0. So then it becomes 4x1 plus 0 is equal to 120. So x1 is 120 by 4 is 30. So this is right. Abrar and Razan are correct. They have found the right values. X1 is 30 and x2 is 40. So we got all the 4 values. So let's write it down here so that it's easier. I did it both at the same time so that I can show you how to decide about the intervals. So x1 values are 40 and 30. x2 values are 20 and 40. Now, what is the range? Here also 30, 40, 40, 20. So we can keep an interval of 10 each. These are the 4 values, okay? 1, 2, 3, 4. The minimum is 20. The maximum is 40. So in the graph, we have to, this is important, to check before we start planning the graph. We should see what is the maximum. This is called range in the data. This is called range, the minimum and the maximum. You must have studied in statistics that the minimum value and the maximum value. This is called range. So here the range is from 20 to 40. So we can keep the same intervals, 20, 10, 20, 30, 40, and 50. No need to go further because we don't have any value more than 40. So we just keep this much. We already plotted the value of, this is x1 and this is x2. We have already plotted the value of x1 on the graph, and that value is here. Then we'll have to plot the value of x2. So what is the value of x2? Here is 20. So here is 20. So we got the 2 values. We just need 2 values, x1 and x2. And once we got it, we have to simply, the rule is to connect both of them. How? Take a scale and connect these 2 values. It's not a straight line I got, but it will be a straight line when you connect it with a scale. So this is the first equation. This line is called the line of constraint equation number 1. Okay, constraint equation 1. And the constraint equation number 1 is 1x1 plus 2x2 plus 2x2 is equal to 40. Okay, so this is the line for equation number 1. So you can make now for the equation number 2. Equation number 2, what are the values? X1 is 20, x1 is 30. X1 is here 30, and x2 is 40. x2 is 40. So what we do, we again repeat the same. Let me just use some scale because on my writing pad I can do that. Okay. second. I have to do it by hand. Okay. Doing okay, so this is 10, 20, 30, 40. This is our first line. This is 40, the second, and 30. So let's connect these two just by, yes. So this is our second line, and this line is called equation number 2, and the equation number 2 is 4x1 plus 3x2 is equal to 120. Okay, so we got something like this. Let's look in the book so that it's more clear there. Let's just go there. So this is our graph. Okay, now we have already plotted these two on the graph, and this is our. So it will be easier for me to show it on the ready graph. Okay. So we see here that the two constraints are now plotted on the graph. We have two straight lines intersecting, cutting each other at a point. So what we should do, we must know a few things. Okay, so please pay attention to understand, because we are now coming to the solution stage. The main step is done. That is, we plotted the two lines on the graph paper. Now we reach the solution stage. So for that, we see a few things in the graph. First of all, the most important in this graph is to see the point of intersection. Okay, this is called the point of intersection. Then the second point that you are seeing here is the gray or colored area inside the point of intersection. You can see this is the point of intersection. This is what we have to identify. What is point of intersection? It is the point that cuts the two lines. So we can see we just drew a line, and we see that the two lines are cutting each other. It's very badly done, because I did it by hand. But you will have to use a scale, and you will do it. Okay, try to do it today. Use a graph paper and use a scale to do it. And when you make it on graph paper, ensure that the differences, so you at least skip 2, so that it's not very small graph. So you make bigger graph. So what we see, that there is a point of intersection. That point of intersection is very important to find. So once we are able to see this point of intersection, this point of intersection is the main main step to find the feasible solution. So what is the point of intersection? Let's take another color so that it's easier for you to view. Okay, so this is our point of intersection. we call this, will give the names to all the points. So what is our area of interest? Our area of interest is this area, this region, which falls within the point of intersection. We are not interested in these areas. We are interested in these areas. This is the area where we are going to find our solution, right? So you have to remember this. This is the area where our solution lies, and so this area is called feasible area, area of feasible solution. Okay, so the area of feasible solution. What is that area? Area within the hat, okay, the point of intersection. Also note one point here. Please note down carefully that in the problem of maximization, this area is we are seeing, but in the problem of minimization, if it happens to be Z min, then what happens? It will be opposite. So suppose this is the intersection point, then the point feasible area will go outside. Okay, this will be the feasible area outside. I'll just show you again. Let me just show you. New slide. Okay. Yes. So here, we have to understand this, that this is the rule, very easy. If this is the graph, these are the two lines. Suppose this is the two lines cutting each other here. So remember this carefully. So what is this called? This is called point of intersection. Okay, this is called point of intersection. This is a very important value for us. This point decides where will be the feasible area. So in case of maximization, this area will fall within the intersection point. Clear? And in the case of minimization, this will be outside. This will be outside the point of intersection. All right. So let's forget the minimization right now. Our feasible area is this. Let's number them. Just make them some symbols: O, A, B, and C. Okay, we name them O, A, B, and C. So we have 4 points: O, A, B, and C that lie on the feasible area. Are you understanding clearly? What do you say? Yes or no? You're getting the point? We have 4 feasible points. One is at O, A, B, C. So how do we decide what is the feasible area? The point within the area within the point of intersection, and the points that touch that feasible area are the possible decision alternatives. These are the decision alternatives. Sorry. These are called the decision alternatives, and from these we are going to find the solution, our solution. So these are called decision alternatives. Right now we don't know, we are just solving it. We don't know which of them is the right value of x1 and x2. So we have got 4 options. One is O, second is A, third is B, and the fourth is C. From these, we have to find which option is the best. And what does that mean? Which option will give us Z max? Okay. So let's look at the values. All right. let's look at the values. We have the graph. Now, I'll make it here. Let's look at point O. At point O, you tell me, at point O, look at this point O, what is the value of x1 and what is the value of x2 at point O? It's important for us to read this. So who will tell? What is the value? 0. Very good. Who answered? Belasan. Very good. Belasan, Abrar, Razan. So at this point, x1 and x2, both the values are 0. I mean, this is logical because it's just started. This is the point of origin in the graph. But this is not a valid, a logical decision alternative. Why? Because it means that the company is not producing any of these. So, but it will always be there in the maximization problem. So, first decision alternative is 0. So that's our first. Now you calculate for A. First of all, let's take A. So at A, decision alternative number 2, A, x1 and x2. What is the value of x1 at A and x2? x1 is 0 and x2 is 20. x1 is 0 and x2 is 20. Very good, mashallah. Abrar is very quick in this. I think she loves graphs. Okay, so x1 is 0 and x2 is 20. That's fine. And after that, who answered? Sulafama and Belasan. Good. So we got this second point. All right. Then let's look at C first. Okay, we'll take the B. Okay, let's take B. B, we have this point and this point. B is an intersection. So at B, we have an intersection of, we have to do some approximation here. But in graph paper, you don't need to do that. Here, because it's not a graph paper, we have to just estimate, we have to make a guess. So when we connect P from here, we find x2 is 10, x2 is 10, and x1 is somewhere between 20 and 30, isn't it? You see, it's not exactly 20, or yeah, we can say 25. That's right. You know, we can say it's 25. Yes, Belasan, Shahad, and Nawal. You're right. So that's our value for B. Now let's look at C. C is easy. You know, C we can easily do because you are good in this. So you can easily say what is the value of x1 and x2 at C. x1 is 30. Very good. And x2 is 0. All right. So we got 4 values. Any other point which is lying on the point of intersection? No. In the feasible area, only 4 points are there: O, A, B, and C. So we got all the decision alternatives now ready. Okay. You will help me in taking this to the next. I'll just erase this one first and. So that I will solve it here. Okay, so I think you are now getting the idea and you must be ready to solve. There's nothing much to do now. It's just a matter of a simple addition multiplication that we are going to do. We have 4 alternatives, 4 decision alternatives. We have to work our original objective function, that is z max is equal to, tell me please, what is the z max? 40 x1 and 50 x2. Okay, z max is equal to 40 x1 plus 50 x2. Now we have got points O, A, B, C. We have got the values of x1 and x2 on both. At point O, the values of x1 and x2 are 0. 40 into 0 plus 50 into 0. So, I mean, you know, I am just explaining to you in a more methodical way so that you and don't forget any step, and it doesn't become mess for you. But in the book, sometimes they will jump straight to the solution, to the answers. But if it's better to follow step by step. At point number A, the value of 1 was 0, and value of x2 is, so x1 is 0, and x2 is 20. 50 multiplied by 20. Please correct me, if I am wrong. I have to go back and check. Okay. B, the value of x1 is 25, right? And x2 is 50 multiplied by 10. 50 multiplied by 10. And at C point, the value of x1 is 30, and the value of 50 multiplied by 0. Okay. Now what we have to do? Simple. Just multiply and add. So you give me the values first for all of them. At point 0, it's 0. Else. At A, the value is 0 plus 50 multiplied by 20 is 1,000. So it's $1,000 total profit. This is total profit. Z max. Z max. Okay. Now, what about point B? 25 for the 100. So 1,000 plus 500. So 1,500. And at point C, the total profit will be 1,200 plus 0. So it will be 1,200. Do I need to tell you which alternative is the best? I don't think I have to, because you are all too smart than me in this. Because you are really good, because in the earlier classes they struggled somewhat, but now I don't have to do much efforts. B, very good. So B is the value we select. B is the decision value. Okay. So why have we selected? Because we have to select. This is a maximization problem. And the value has to be the maximum. So 1,500 is the maximum profit. And how are we getting 1,500 profit? When we make how many? 25 bowls and 10 mugs. So this is the answer. All right, this is the answer. X1 is 25, X2 is 10. Now, if it is a minimization problem, if it is a minimization problem, first possibility is that there will be no 0. It will not come 0. But even if it comes, we will not select 0, because 0 is not a logical decision alternative. Why? Because what does 0 mean? 0 means that you are not producing anything, which is not a feasible, practical alternative. So we will not take 0 as an alternative, even in minimization, because minimization will be what is the minimum value we can get, or the cost we can minimize. So it can't be 0, because 0 means what? 0 means the company is not working, it's stopped. So that is not a feasible possibility. The feasible possibility will be from among these three, what is the minimum? So 1,000 is the minimum, we'll select 1,000. So it's the same, exactly same process in minimization. The only difference is there. What are the main differences I told you? Do you remember? In minimization, one difference is that the feasibility area lies, this is the point of intersection. The feasibility area lies outside the point of intersection. Okay, you got it? So once you know this, before that, we already know, we have to do the same steps. Find the values of x1 and x2 from the constant equations, plot them on the graph. There can be more than two graphs also. If there are more than two constraints, then we'll simply make the graphs and they'll connect each other. But generally, that will become more complicated. So manually, we just try to understand with two. But if you are using computerized solutions, then we can take as many variables as constraints as possible and variables as possible. So there, the feasible area will be outside. And this feasible area means these points will be the decision alternative. Then we repeat the same. We will find the values of Z min, that will become Z min, and we'll find the values at these points. And finally, we will select the lowest value there. But here it's the highest value. So that's the only difference between maximization and minimization. I mean, I just stopped at maximization because it will become you will become overloaded with syllabus for exam. So that's why I just thought let's stop at maximization. Okay. Now tell me, any problem to any of the students? Because this is done. If it is in that mean it is max. Yes, not, yeah, we will make it in. Okay, if it is inside, I mean, when we are drawing, so if our task is to find the feasible point of intersection. So once we have found the point of intersection and the problem is of Z max, the rule will be to consider this area. This area is called the feasible area. If it is a minimization problem, we'll consider the area outside the point of intersection. This will be the feasible area. We are not considering this. Why? Because this is common to both. It should be common to all. Okay, it should, this area will be common to all the points. So this is, you see, this is common to all the points. Here also, this area is common to all the points O, A, B, C. All of them are touching here. It's not like only two are touching or three are touching. All four are touching, are being covered by this area. Similarly, all the three are being covered by this area. This is for minimization. This is for maximization. So this is how we find the value of the decision alternative and final answer for the maximization function or minimization function. With this we stop at linear programming. But linear programming is not just this. I mean, when you will learn more, you go to higher classes, you will learn about linear programming with dummy variables. You will learn linear programming with simplex and more complicated problems. But we have learned the basic linear programming model. The main rule to solve it is to formulate first. So unless we are able to write these equations clearly from the problem, so we will get an unstructured problem. We have to convert first into a structured model. If we have been able to do that, then we can choose any method and solve. So in the graphical, these are the steps that we have to follow to find the solution. I think this is all for linear programming. I just thought this is enough. Now we have to see if there is a class next week. Then I'll take a special class. It will be slightly bigger than this one, and we will cover some not just one but more than one topics in one class, so that we can cover as much as possible. If there is no class in the next week, then means I'll ask someone, some heads, to tell me if any special class is possible. If nothing is possible, then this is the last topic for the exam. Okay, so I stop the recording. You can now tell me, if you have any further doubt, you want me to explain anything more, I'll be happy, because in this time in final exam there will certainly be